Hi everyone, my name is Clem. I'm the co-founder and CEO at Hugging Face. Super happy to be with you virtually today. So Hugging Face arguably is the most used machine learning platform out there with more than 10,000 companies using us, including, as you can see in this screenshot of our homepage, Microsoft, Google, Typeform, Grammarly, Amazon, Facebook AI, and more. We're basically a platform for companies to build better machine learning. And today with you, I wanted to talk about a topic that I think we need to talk more about in machine learning, which is machine learning ethics, and kind of like why and how to care about machine learning ethics, especially when you're building machine learning models and machine learning systems. So first, why do I feel like that we need to talk and do more machine learning ethics today? Usually when you think about how important it is to think about ethics, about biases, about impact, you want to look at two things when it comes to technology. First, you want to think about how much harm the technology can do, right? For example, if there's a technology that can't do any harm, then it doesn't really make sense to spend a lot of time and a lot of effort into thinking about ethics. The second thing you want to look at is how many people it impacts. And I truly believe that for machine learning, we are today at the turning point when it comes to these two things. First, how much harm it can do. And here I want to kind of like remind something to everyone, which is that most machine learning models today are heavily biased, right? Example of that is BERT, arguably the most popular machine learning model out there today, extremely popular. If you take this model as I did here, and you're doing a task called mask filling, meaning removing a word and asking the model to predict this word, you see that the model is heavily biased. If you give it "this man works as," the words that you're getting is lawyers, carpenters, doctor, waiters, mechanic. Whereas if you feed it with "this woman works as a," you're getting nurse, waitress, teacher, maid, prostitutes, right? BERT is heavily biased. And so when you think about using it, for example, on resume filtering, hiring, for example, you can see and you can understand pretty intuitively that if you're not careful, this can be harmful to some people, especially here with this example to women, because it's displaying a pretty heavy bias. So now the second thing that you want to look at in terms of like why and when to work on ethics is how many people it impacts today. And I want to share kind of like something that I've noticed on the most popular consumer products today. So we can start with kind of like probably the most popular consumer product out there today, Google, right? Arguably billions of people are using every day Google, other search engines like Bing. And what they've been announcing for the past few months is that most of the research results are now powered by machine learning and by transformer models, right? The similar ones that we've talked about with bias before. Not only does the search result is powered by machine learning, but also new features like question answering that I'm showing here, meaning when you ask a question to Google, then it's going to scrap the first page of results and look for the answer and then extract this answer and show it to you in the first box, right? So arguably today, the most popular consumer product is powered by machine learning, right? You could say, oh, it's just Google, it's fine. And then you look at something else like Gmail, right? Probably the most popular productivity tool out there, right? Email client that hundreds of millions of people are using. Now, one of the biggest features there is something called autocomplete, right? Which is suggesting the end of a sentence when you start to writing. This is powered by modern machine learning, by transformer models, right? Then you could say, okay, it's just Google, it's just productivity. And then you look at social networks, right? Facebook or Meta, should I say, but also Twitter, LinkedIn, all the others. Now they heavily powered by transformers and by machine learning on things like automatic translation. Obviously, super useful for me as a French native speaker. You'll see that on everywhere you go now, you see automatic translation that is powered by machine learning. And then you could say, oh, it's fine. It's just, Google, it's just productivity tools, it's just social network. There are a lot of kind of like technical topics where you don't really use machine learning. And maybe you've seen the announcement from GitHub not so long ago, arguably the most popular software building platform that I think they announced 7 million developers are using to build software. One of their most prominent new feature is something called Copilot, using transformers, using machine learning to suggest the next lines of code when you're developing, right? So high level, whether you realize it or not, machine learning is starting to be the most used technology out there. Like you see, it's everywhere, all day, every day. Now you're going through products, you're using products that are powered by machine learning. This is why it's extremely important today, not tomorrow, not the day after tomorrow, but today, to talk about ethics, to think about ethics, and to do things about ethics to make sure the impact of this new technology is positive. This is one of the reasons why at Hugging Face, we're super happy to add to the team someone I respect tremendously called Dr. Margaret Mitchell, who was previously the co-head of the ethical AI group at Google, and who's helping us at Hugging Face to make sure that everything we work on is driven by ethical considerations. And just to be transparent, most of the rest of this talk, of this keynote, of this presentation is heavily inspired by Dr. Mitchell's work on ethics and some of the kind of like framing that she's had in order to integrate her work into our practices at Hugging Face and hopefully at the broader machine learning field. And I hope that what I'm going to explain today is going to inspire some other companies working on machine learning to start to be really serious about these topics. So first, when you want to kind of like get a bit more practical about machine learning ethics, Dr. Mitchell usually starts with asking the question, what is ethics in AI, to be able to kind of like get the right framing, right? And we need to move away from simplistic conception and thinking around ethics by thinking that it will provide like an answer to any question and solve a lot of our moral issues. This is not the case. The goal of ethics in AI is to provide a way to analyze problems in light of human values. And these human values are going to be different across cultures, they're going to be different across companies, across societies. So you really have to define them as a company, as an individual, to be able to inject them into the analysis of your problems, right? And values could be things like, honor, kindness, equity, inclusion, commitment, cooperation, honesty, integrity, and more. And then once you've kind of like started to kind of like narrow down kind of like the values that you have as a company, as an individual, you want to kind of like look at how you're building machine learning, right? And usually when you think about building machine learning, there are like 4 different steps that we can differentiate in a machine learning development pipeline, right? First, you're starting with like the training data, right? And how you to collect it, how to annotate it, where can you find it, how is it structured, and things like that. Then once you have kind of like the data, and I'm sure there's going to be a lot of discussions during this event about that, you are going to pick a model, train a model, fine tune, pre-train a model. Then after that, you're going to usually apply some sort of like post-processing, or you're going to build infrastructure, you're going to build the more like software structure around the model, around running the predictions. And then finally, you put your system in production, and users or customers are going to interact with the system, right? Now, let's think about each one of these steps and see some of the ethical challenges that are present, right? So first, the data, right? You look at the data and think about what are the challenges there, and you realize that there are so much human bias in there, right? Especially if you work, for example, on NLP, right? So text AI, as we've been doing it at Hugging Face. You know that text is a social construct, and so it's going to encode a lot of the human biases, like gender biases that I was showing, for example, from birds, are coming from there, right? You get things like reporting biases, selection bias, stereotyping, racism, under representation, right? So it's extremely hard for machine learning, because even before you started to do anything, your data is already kind of like somehow biased, right? With like a subset, snapshot of reality. When you think about large language models, for example, they're trained on a subset of the web, with a big part being things like Reddit, Twitter, and it's obviously a subset of the reality that contains a lot of biases, and a lot of problems there, right? Then when you think about the fact that you have the data and you're kind of like picking a model, training it, again, you have a ton of human bias, right? Things like default effect, meaning that because most people are using BERT, for example, you're gonna default to using BERT as a model, whereas maybe you could have used Distilbert, maybe you could have used Roberta, maybe you could have used T0, which is like a new model that the Big Science project released a few weeks ago. You're gonna have a ton of other kind of like biases creeping in, like overfitting, underfitting, and coring biases, and more, right? Then after that, you move on to filtering, kind of like post processing. An interesting thing here, or lack thereof, right, is that you usually encode even more biases, and that is sometimes kind of like related to the people who are working on this post processing, which are sometimes not really diverse at tech companies, to be frank, in terms of like gender diversity, racial diversity. And so you sometimes kind of like end up with creating even more biases there. Um, good example of that is I remember a team telling me about the fact that they fine tuned kind of like a language model, and they wanted to avoid the language model generating any kind of like sexual connotations, right? So they did some post processing and removed from the generation everything that was containing the words like sex and sexual, and it actually kind of like created so much more bias because, for example, it removed any notion of transsexuality, which is obviously a big problem because you create like underrepresentation in the results, in the application of your models, right? Um, and what's interesting also here is that even when you put your model in production, then sometimes you create this thing where because your users are using your models to create new data, if all the previous steps have been biased, then you create even more bias, right? You can think of it, for example, with autocomplete, right? The fact that now you have systems that can write content for you, right? And if these systems are biased, they're going to create a lot of content on the internet that is biased. And this content is going to be used in the next generation of models as a data set. And so you kind of like have this sort of like network effect. I think Dr. Margaret Mitchell is calling that bias laundering, right? In the sense that bias is going from one stage to another and kind of like being laundered. Or I think we could call it also bias network effects, in the sense that the more bias you have at each step, the more bias you get at the end. And it's kind of like a network effect for bias. The cool thing, in my opinion, is that if it works one way, it works the other way around, right? In the sense that if you can start mitigating the bias at any step of the process, then you can have probably kind of like a positive virtual cycle in a way, in the sense that if you mitigate a little bit of the bias, and then a lot of content is created from that, or you kind of like managing to change a little bit mentalities, then it's going to kind of like fundamentally change, and hopefully you can actually bring social change that is kind of like much more impactful than would with typical technology, thanks to this feedback loop, right? At the high level, I think what we've seen here is that the machine learning development, or the kind of like building of machine learning and machine learning in general is not value neutral, right? Like you can see a lot of biases creeping in, which reinforces the need to kind of like think about values, right? We talked a bit earlier about how edX is injecting values into your processes. That's what we need to do, and that's what we've started to do for machine learning. So, as an example, let's take kind of like all these steps that we talked about, and let's see how we can apply some values to it in order to change the way we do things, right? So the first one, training data and collected and annotated. We can think hear about topics like copyright of data instances, to make sure that the data set that we're using are fairly attributed. You can think about consent of data providers. You can think about fair pay for annotators, which is becoming more and more of a problem. And then finally, you can think about diversity in what the data represents, right? You can really be intentional when you build your data sets, not only kind of like to get the best performance you want, but also to think, is it a good representation of our society? Is it a good representation of who we are as humans? And kind of like impact thanks to your values, the way your data sets are built. Then when it comes to the model, we think it's important to think about the appropriateness, of your model, of your loss function, of your evaluation, and not just in terms of like performance, not only kind of like based on, am I getting the best F1 score with this model, but also in terms of, is it appropriate for my use case, right? We talked about BERT for filtering. If you know that there's kind of like this bias, is it appropriate for me to use this model in this use case? And if it's not, you should probably not use it. Then when it comes to post-processing and kind of like the software surrounding the machine learning model, I think you want to think about, fairness of outcomes. You want to think about diversity of choices, inclusion of the users, and things like stereotype removal, which are kind of like ways for you to augment the models and kind of like fix and mitigate some of the bias that the model in itself could have. And finally, when it comes to the usage of your machine learning models in production by users or by customers, I think you want to think about minimizing social harm, minimizing what we call dual use, right? Which is use of a model for risky applications, and you want to kind of like boost positive use cases, right? So let's say you're doing like an autocomplete, a content generator model. You want to kind of like try to motivate and incentivize people to create, positive stories, right? Positive things, rather than have them kind of like creating negative ones, right? So these are kind of like a bit like theoretical. So as kind of like a next step, I wanted to take just two. There are a lot of them, but I think just two examples of how we used some of this process of this framework at Hugging Face to implement actually completely something in the platform to align with our values, right? So here, for example, I talked a lot about how important it is to pick the right model for the right use case based on what you know about the bias and the limitations of the models. One of the challenges is most people don't know, right? When I'm looking at the model, at the BERT or Roberta, in the past, it was really, really hard to know if they're biased, to know what are the limitations, right? So a lot of the work that is being done there is around the concept that is called model cards, designed actually by Dr. Margaret Mitchell, which is kind of like this framework to add to the model reporting things like transparent documentation for benefits, for harms, for risks, for biases, why certain metrics were chosen for the model, evaluation tests and results, which creates really like a transparency and the better way for you to remove your bias when you're picking a model, and trying to find kind of like the model with the least bias for your use case. And it's been pretty cool because at Taking Face, so I think it's a screenshot from a few weeks ago now, we have over 30,000 models that have been shared on the platform. Obviously very popular ones like BERT, DistillBERT, Roberta, as you can see here, but also thousands of others fine-tuned a specific use case. And thanks to us pushing the model cards, we've seen more than 5,000 model cards that have been shared on the platform with things like biases, limitations, benefits, harms a model can have. Which we think really helps the whole field kind of like evolve towards more responsibility when it comes to picking, choosing, using models in production. Another initiative that we've had, which is more on kind of like the diversity of what the data represents here. One of the challenges in the field of NLP is that it's very biased toward English, right? Because a lot of the research, a lot of the data sets, a lot of the models work well for English, but not so much in other languages. And so it creates a big bias and big limitations in terms of like diversity of the data. So what we did is it's a big, what we call community sprint with, I think there was 400 researchers who contributed to create the first models for Wave2Vec, which is speech to text. I think for 100 different of what we call low resource languages, which are languages that are not worked on so much, where it's hard to find a data set, where it's hard to find a good model. We did that, I think, for a week and a half, and got hundreds of new models created for low resource languages, which is kind of like pushing this diversity in terms of like training data, this diversity in terms of models in different languages to represent better the whole world rather than just like the English speaking worlds. And this is just two examples. This is also just the beginning. I truly believe that there's a lot more potential to include value-informed processes into NLP, into computer vision, into speech, into time series, into biology, into chemistry, into all the machine learning fields. And to improve, frankly, the outcome, the positive outcome of this model and the capabilities for this new technology, which I believe is going to be the most impactful technology of the decade. We have a way to make it like a positive force in the world, right? If you think about a lot of our society's problems, from climate change, vaccines, toxicity of public platforms, machine learning can and should help more, right? For example, we've been talking a lot about social networks lately. Facebook becoming Meta. You can't have on Facebook a human to check for every single racist and violent comments, right? You can have humans in the loop, but you also need machine learning to help you in there, right? So we need machine learning to help on positive use cases, and we need to be more value informed when we build machine learning systems, right? And that's the only way for me for it not to only be the most impactful tech of the decade, but also the most useful and positive for the world. That's it for me. If you're interested in keeping the conversation going, feel free to check Hugging Face, right, on huggingface.co. Reach out to me directly on Twitter and LinkedIn. Thank you and enjoy the rest of the event, everyone. Bye-bye.